Hello, this is a problem from Openstax Calculus Volume 1. It's a free book. You can see the online version on openstax.org under Math, Calculus Volume 1. So this is implicit differentiation. There's actually the problem's worked out, the example's worked out there. And what we want to try to do is find dy dx using implicit differentiation. And so what I'll do is I'll write down the problem. So here's my solution. I write down the problem and I apply the derivative with respect to x to both sides of the equation. So under implicit differentiation, we do not solve for y. It's not y equals whatever, x to the third plus, etc., some stuff with x. It's y is, sort of mixed in with our equation. We can't solve for y in this, I don't believe, in this equation anyway. All right, so what we're going to do is just go through and take the derivative of each of these pieces with respect to x. Now, the first part I'm going to focus on is this this part here that says x to the third sine y. And to do that, I need to use the product rule. Sort of always worried about writing an arrow. It doesn't mean limit or anything like that. It just means look over here, I guess. So I use the product rule, and I'm going to take the derivative of the first factor and then leave the second factor by itself. Leave it untouched. Then I write down the first factor and then the derivative of the second factor. That's the product rule. And I haven't taken those derivatives. I'm just writing that down as an outline, I guess. And then over here I have this for y, the derivative. And then for 4x plus 3 on the right-hand side, I just walk through and take the derivative. 4 times x is what? What is the derivative? The derivative of x is 1, so I get 4 times 1, which is 4. And then the derivative of 3 is 0. So back to this part over here, the derivative of x to the third power is 3x squared times sine y. And then the derivative, so the derivative of x to the third power is 3x squared. And I multiply it by sine y. Then I have x to the third, and I take the derivative of sine y. Now, for sine y, the way we can look at this is we can say that this is a composition, and we're going to use the chain rule. That's the whole thing with implicit differentiation. We use the chain rule. So we look at the outside part and the derivative of sine of whatever, in this case y. The derivative of sine y. All right, so what do we get? We take that derivative and we get cosine, and then the chain rule says I just copy whatever's inside. So I copy that, but then I multiply by the derivative of what's inside, and that I write down as y prime. So in practical terms, when you're taking the derivative with respect to x, when you come to sine y, you just take that derivative, cosine y, and then you put on, multiply by y prime. Over here in the next part, y, the derivative, could be thought of as 1, but then we multiply by y prime. But this is just y prime. You see, we take away the parentheses, we get y prime. And we have 4 on the right-hand side. Now what I'm going to do is I'm going to solve for y prime, and I have an algebraic equation, and I want to solve for this unknown y prime. And with algebraic equations, we solve using the reverse order of operations. So we started with addition and subtraction. And what I'm going to do is I'm going to bring this piece that does not have y prime, or what we're trying to solve for, it does not have y prime. I'm going to subtract to bring it to the other side. So that leaves x to the third cosine y prime plus y prime equals 4 minus 3x squared sine y. Right, so I subtracted this from both sides, and now it's over there with a minus in front. And now I'm going to look at this y prime in two places. I'm going to factor that out. Now, okay, so what do I get? I'm going to get y prime, and left behind is x to the third cosine y, plus, well, this piece here, the second term, is, you could be thought of as y prime times 1. So what's left behind is 1 when I factor out y prime. Right-hand side, I need to take the time out to copy it down, even though it's exactly the same. I haven't done anything on the right-hand side. And now I divide. And getting my answer. And this is the answer in the book. I'm going to do something that's sort of maybe not at all necessary, but I'm going to reverse the order and put this 1 in the front. And the reason I'm going to do that is it's sometimes someone, you don't want to think this is cosine y plus 1 in parentheses. It's true I have the parentheses so that you don't have that confusion, but anyway, might as well, since I've gone this far, try to make it as good as I possibly can. I should also try to write neatly to make my work as nice as possible. Oh, gosh. Okay. So that's the answer. Let's go ahead and highlight that and check that off our list of things to do. All right, so from Openstax Calculus Volume 1, we did implicit differentiation. So I guess that's all. Thank you. Goodbye.